Point-slope form. What is it? What is this mysterious new form we're talking about? The essential question for today poses just that question. What information does point-slope form give me about a line? And how can I use that information to graph the line? Let's learn about a new format. Previously, we had learned about slope-intercept form, and it gave us the slope and the y-intercept. But today, point-slope form, unsurprisingly, gives us a point in the line and the slope of the line. Can you identify the slope in this equation? That's right, it's m, same as slope-intercept form. But now, instead of it being mx plus b, I have this other stuff. So first of all, this is a format you do need to memorize. We need to memorize y minus y1 equals m times x minus x1. Very, very important. We know that the m is slope. This y1 and this x1 are a particular point. A particular point in the line. It doesn't have to be the y-intercept. It can be any point. And we call that point x1, comma, y1. So this is literally any point in the line. This x and this y refer to all of the other points that I could plug in, but the x1 and the y1 stay the same. So point-slope form, you need to memorize it. An important feature is that I have a minus here and a minus here, and we'll talk about what that means. On this slide, I want to graph the following lines. Now notice, both of these lines are in point-slope form. Why? Because they have something added to the y and the x inside parentheses. So this is point-slope form. This is not simply y equals mx plus b. This is y minus y1 equals m times x minus x1. Now, it's easy to identify the rise and the run. Here's the slope. The slope is 2/3, so that means my rise is 2, my run is 3. But what is the point that I'm given? Notice that since I have a minus sign in here, x1 is 3. So my point is 3. Notice that's kind of the opposite of what I would think it would be. Some people, when they look at this, they think, oh, this is minus 3. But because of the minus in my formula, this is actually an x-coordinate of 3 in my point. Likewise, the y-coordinate is also backwards. See how I have a minus in the formula but a plus here? I could turn that plus into minus -2. Now the minus lines up, and I see that my y1 is -2. So the key thing to remember here is that this formula lies to you. This is the opposite of what you think. This is the opposite of what you think. My point, instead of being -3,2, is actually 3, -2. So the formula is kind of lying to us. It's backwards. Anyway, once we know the point and the slope, I can easily graph it. Just like in slope-intercept form, where we started with the intercept, here I'm going to start with the point. So the point is over 3 down 2. That's right here. Then I'm going to apply the slope. We said the slope is rise of 2, run of 3. So up 2 over 3, up 2 over 3. I could also go down to left 3, down to left 3. Here is my line. That's the first line. Now let me change colors and we can look at the second line. Let's change to a nice royal blue color. With this second line, okay, first I can identify the slope. Remember, the slope is this one. The slope isn't just negative. Remember, if I don't see a number there, really it's the invisible number 1, or in other words, -1 over 1. So my slope is -1 over 1. It's a rise of -1 and a run of 1. What is my point? Remember, the formula is lying to us. This -2 actually means an x-coordinate of 2. This -1 actually means an x-coordinate of 1. Not -2, -1, +2, +1. The formula is a liar. Much like politicians. Let's graph this. I start at the point over 2, up 1, and then my slope down 1, over 1, down 1, over 1, down 1, over 1. That is a nice line. All right, moving on. Sometimes they will ask us to write the equation of a line in point-slope form for the following points. This is actually easier than writing the equation of a line in slope-intercept form. And the reason is because instead of having to plug in points and then solve for the b like I did with slope-intercept form, all I have to do here is plug in a point and I'm done because it's point-slope form. So let's get right on it. In point-slope form, obviously we need a point. Well, I have two, so I'll be able to choose one of them, but also I need the slope. So let's find the slope first. You guys are pros at finding the slope by now. M is going to be equal to y2, 13, minus y1, 19, over x2, 5, minus x1, negative 5. This is, let's see, 13 plus 19 is 32. 5 minus negative 5 is 10. I can reduce this fraction by dividing the top and bottom by 2. That would give me 16 over 5. That's a pretty complicated slope, but remember, I'm plugging into the equation y minus y1 equals m times x minus x1. So I'm going to put this slope right there, and it doesn't really matter that it's complicated. I can just plug it right in. Remember, the other thing that I need to plug in is the point, and I actually have two to choose from, so we have two different possibilities for our formula. Possibility number one is if I chose this point. I'm going to plug negative 5 in for the x1, I'm going to plug negative 19 in for the y1. And remember, when I plug them into the formula, I keep the minus sign in the formula. Here's how it's going to look. Y minus the y coordinates, negative 19, equals 16 over 5, x minus the x coordinate is negative 5. Let's change these double negatives into a plus in both cases, because remember, the formula is lying to us. It's giving us a minus in the formula. So if I actually have a negative in my point, how it's going to look in the formula is y plus 19, x plus 5, and the reason is because the negatives cancel. So this is one possibility for a formula I have, but here there's actually a second possibility. What if I plugged in this point? In that case, it would be y minus 5 equals 16 over 5 times x minus 13. That's another possibility if I plugged in the second point. So both of these are possible answers. On the test, you would probably just need to give one of them, and I would accept either one as correct. And that's all I have to do. It's not like slope-intercept form where I have crazy complicated things to work out. I'm literally just plugging in the slope, which is easy to find using the formula, and the point. Guys, that was it. As a summary, remember, point-slope form, you need to have this memorized. y minus y1 equals m times x minus x1. Memorize this bad boy. Memorize it. That is all for today. Nice short video. Maybe you can use the extra 2 minutes that I didn't use with the video memorizing this guy. It's important. Bye-bye.